For example, when lava carves a channel, as it's sloshing around, some of the lava will go up on the banks of the channel, and what happens is that it solidifies there, so it actually builds little levees along the edge of the channel. We don't see that. The most distinctive thing is that many of the channels on Mars have well-developed tributary systems, branching and branching and branching, and that's very hard to explain as lava channels. So I think we can say with a pretty considerable degree of confidence that what we're seeing in the case of the valley that flows into Gusev Crater is that it is water-carved. There are places on Mars where we do see lava channels, but it's possible to distinguish between the two on the basis of their morphologic details.
Sir.
We know that there's water on Mars for certainty because of Phoenix. Any desire to put a rover in the polar caps, or are you afraid you're going to lose it to
The question is, would there be any desire to use a rover in the polar regions? You know, it's tempting, but I think the polar regions are actually better suited to stationary landers that provide you with vertical mobility. If you looked at those Phoenix images, it was pretty much the same in all directions on the surface. The polar deposits of Mars are very flat, and you can travel for long distances over the surface and see very much the same thing. The interesting story lies below the surface, and there's a very detailed stratigraphy below the surface that is telling us about climate change on Mars. And so to me, if I were able to do a follow-on mission to the polar deposits, rather than sending a rover to kind of go trundling across the surface and see the same thing over and over again, I would do the same thing that people do on the polar plateau in Antarctica, and I would drill. I think that's where the really interesting science is the vertical mobility.
Yellow shirt.
Concerning drilling, do you have any idea of the possibility of drilling down with a robot, maybe 100 feet, 200 feet, 300 feet?
Yeah, that's a very good question. Drilling, deep drilling with robotic systems on Mars. I'm actually going to have the chance, as will Robert Zubrin, next week to talk to the Augustine Commission. I'm in the process of writing my testimony for that right now, and one of the things that I'm going to be talking about is some of the science that humans could do on Mars. And I believe that deep drilling is one of the most important pieces of science that we might eventually do on Mars, because it could get down to depths where liquid water is present today with all that implies. And B is one of the tasks that I simply cannot imagine doing robotically. Deep drilling requires hundreds of meters of pipe, man. I mean, it's a lot of stuff. You ever been to a drill rig? I mean, these are big, complicated things. And I just have a hard time believing that you could pull that off robotically in any reasonable time scale. So I don't think that's a task that's well suited to robots. I think that's one that's well suited to humans.
The white shirt.
Have you found quartz, or do you think you'll find quartz?
Have we found quartz? No, we have not found quartz at all on Mars. We have found silica, SiO2, but it's amorphous silica. In particular, it's hydrated amorphous silica. It's opal, sort of like the gemstone, only all ground up. But nowhere have we found quartz, and that's a mineral that we would be able to identify pretty easily. So we haven't found it. Excuse me?
Do you think you'll find it? I mean, is it?
You know, I think at this point I'd have to say it's unlikely. Mars is basically a basalt planet. Basalt doesn't have as high a silica content as some other rocks, and so it doesn't tend to have a lot of quartz in it.
Right here.
How much has the solar rays degraded since day one?
How much of the solar arrays degraded since day one? What do you mean by degraded?
Well, power-wise, have you noticed that you've lost power since day one because the solar rays have degraded abrasion or whatever?
The only loss of performance that we have seen from the solar arrays is from the buildup of dust on the arrays, and that is a purely reversible process if the wind cleans them off. So the arrays have not degraded at all, except insofar as they have gotten dirty and then, sometimes gotten clean again.
Blue shirt. Lady.
The landscape that I saw on this film had a blue cast of color.
Yeah.
The shadows seem to have a blue cast. Is that true, or is that the film?
In the images, she's asking about some of the bluish tone that you saw in some of the images. The images in the film are a mix. Most of them are what we call approximate true color, which means it's our best attempt to get the color exactly as your eye would see it. And the vast majority of the images in the film are of that sort. There are a few, especially in the closing credits, that are what we call false color images, and there the contrast has been enhanced, and so things that are slightly bluish look much bluer. But there's really nothing truly blue on Mars.
Right there. Yes, sir.
I was just wondering, like, I noticed in a lot of,
Can you speak up a bit, please?
in a lot of, like, documentaries and movies about, like, transmissions to Mars and, like, what the craft that we sent there, they only say 2/3 have failed, but, like, the majority of that's, like, Soviet or Russian, like, they always do, like, a disclaimer, like, that NASA's mostly successful.
Yeah, what has been the failure and success rate for NASA missions to Mars? The thing that drove it home to me was simply that the two immediately before ours failed. And that kind of shaped our environment. I think, yeah, if you stack it up with the successes now of Phoenix, Spirit, Opportunity, plus the recent orbiters, NASA's success rate at Mars is actually pretty darn good. And in fact, I think the human race's success rate is starting to creep up towards 50%. But it's still, don't take away from that we've got Mars figured out. It's still a damn hard place to do business.
Far left side.
Based off of what you just said, and you talking about MSL, I've had a number of friends say, hey, those things are in their 5th year of their 90-day mission. Why aren't we just mass producing more of those and sending 50 of them to the sun? And using those, it's something new. We've proven they work. Why not?
Why aren't we mass producing Spirit and Opportunity? It's a complicated question. Part of it is that NASA just historically has not been an agency that flies multiple copies of something that works well. They tend to want to go on to the next thing. And that's sort of driven by the personality of the agency, by the personalities of the people who are within it. Mars is a complicated enough place. It's a diverse enough place that you could throw down 8 or 10 or 12 or 50 of these things, and each one would be finding new things. I think the idea has some merit, but that is not what the agency has chosen to do. And to do so would go very much against the historical trends within the agency.
Sir.
How will that lava get at the Gusev to start with? I've never seen it up this volcanic.
The question is, how did all the lava get into Gusev crater in the first place? It's actually very common on many planetary bodies. Mars is one of them, but the moon is a great example. Okay, on the surface of the moon, you see these large craters that are filled with very low viscosity lavas. The vent gets completely buried. If the viscosity of the lava is low enough, it rises along fractures, quite commonly fractures that were created by the impact in the first place, and then it comes to the surface and it just smooths out and forms a nice flat puddle, and it buries the vent completely.
Blue shirt.
Along the lines of what Mr. Butler was talking about a few moments ago about the still images of Arnold Schwarzenegger over a long period of time, do you have time-lapse photography, just a still image every day of the rover mission that can be strung together to give the appearance of a continuous stride? And why was that considered for incorporation into the movie?
I can answer the first part of it, in that there are some images, particularly with those hazard avoidance cameras, the ones that are down low. Every time we do a drive, we take a set of those. And in fact, movies of that have been created, and they're kind of fun to watch. They're very herky-jerky, but I remember one that was, I think, when was it done? It was like, I think it was after we'd been on Mars like 1,000 sols. I think it was to celebrate 1,000 sols. Somebody took 1,000 sols worth of those things and strung them together, and you were kind of like this by the end of it. But it was cool to watch, and you could watch the whole mission unfold in about 2 minutes. I think as far as considering it to go in the IMAX film, you'd have to ask George.
It's a wonderful idea.
Next film.
To the right, you, sir. Right there.
As you mentioned earlier on, as a movie director, would you project the societies also project to a movie, find it interesting, a movie on the life of Dr. Robert Zuber and the struggle.
The answer to your question is that I've made a very good move.